Hello, everyone. I hope you're doing great. So, this is in continuation to the blog post which you must have gone through. It's about synthetic division. So, another important topic in algebra, especially when we are going through the rational functions or the polynomial division. Uh, so, there is already a method to divide the two polynomials, which is called the long division method, which works for any polynomial of any degree, but definitely it takes somewhat it takes a little more time when compared to the synthetic division. So synthetic division is another way to do excuse ourselves with the long division, but to get the same results. So I'll just start with a question, and from that question I will explain what is the method to do the synthetic division. So let's say there is a dividend, and by the way, before moving on to that, I'll explain that in the division there are actually four important terms which we must be aware of. One is, let's call it dx with a capital D. It's called dividend. Then with a small d we have the divisor. Then we have with a q we have the quotient, and then with r we have the remainder. So why there is an x with all this? Because all these are a function of x. So that's a way to write it, that rx means r is a function of x, means remainder is a function of x. So these are the four important terms which are to be worked with in synthetic division, or in any kind of division, and the relation with which they are connected is dividend, or in fact I'm going to write in terms of the variable. So that's dividend is equal to the divisor multiplied with the quotient plus the remainder. There is another way to write this. If we divide both sides by divisor, then we have the dx over small dx. It means that the dividend is divided by divisor to give us quotient plus the remainder over the divisor. So these are the two ways to write the same relation between these four terms. So this is something worth remembering. Right. So let's start now with our first question, and let's see how to. First, I'm going to divide this. The question is 5x square minus 3x minus 36, and that should be divided with x minus 3. So first I'm gonna do this with the long division, and and then I'm gonna frame the setup for the synthetic, and we'll talk about that. So for the long division, we are going to write it something like this. So this is where the dividend comes, which is 5x square minus 3x minus 36, and this is where the divisor comes. And we can write either a quotient over here or quotient on the top. So I'm going to write it on the top. So I'm going to extend a line over here. So the first thing is 5x square must be divided with x. So 5x square over x is just 5x, and then 5x must be multiplied with x and negative 3. So 5x when multiplied with x gives us 5x square, and this gives us negative 15x. So this is how we are going to write. The terms of x square is going to be written below the terms of x square. So in other words, the like terms should be in the same column. We're going to subtract it, so the signs is going to change, and this will be cancelled, and 15 minus 3 is just 12. So here we have a 12x minus 36. So I'm going to repeat the same procedure once again. 12x will be divided with x to give us 12, and then 12 will be multiplied with x, and 12 will be multiplied with negative 3 to give us 12x minus 36. So we're going to again subtract, so sign is going to change, and 12 minus 12 cancel, and this is also cancel. So in other words, the remainder is 0. We stop the division when as soon as the degree of the remainder becomes less than that of dividend, or it becomes 0 entirely. So this is something which I mentioned in the blog as well. So this is the result, and how are we going to write this? So we are going to write the result as the 5x square minus 3x minus 36 when divided with x minus 3 gives us quotient as 5x plus 12 plus the remainder as 0. So we are not going to write plus 0. So this is how we are going to write this particular, let's call it the result of this particular division. So this is from the long division method, which is the traditional way. Now I'm going to draw a line over here, and let's continue the synthetic division on the same page so that we can relate how it's working. So it's synthetic division over here. So for the synthetic division, we are going to drop down the setup is like this. We can synthetic division works only with the coefficients. So the question is 5x square minus 3x minus 36 is the dividend, and the divisor is x minus 3. So what we do is and by the way, one thing which I want to mention, in fact, at this on this page only, that there were certain limitations of synthetic division, that the first one is, I'm going to write that it's limitations. Limitations is, first is the divisor must be of the form x minus 3. So the divisor must be of the form x minus k. And the second one is the divisor must always be linear. So divisor should be a linear. It means that it should have a degree of 1. So these are the two things which need to be there in order to continue for synthetic division. So the procedure says that drop down the coefficients of the divisor in a single line like this. So 5, negative 3, and negative 36. These are the coefficients of dividend. Draw a line, draw a T-shaped, draw an L-shaped, L-shaped, this symbol or shape like this. And over to the left over here, change the sign of the constant of the divisor. So the constant of the divisor is negative 3. Change the sign of it so it becomes 3, and write this over here. Now, step 1 says that we drop down the first term as it is. So this is dropped down right away like 5. And if it is dropped down like 5 right away, then we multiply 5 with 3. So where 5 when multiplied with 3 gives us 15. So 15 is written over here, and these two are then added. So negative 3 plus 15 is 12, and again 12 is multiplied with 3 to give us 36, and these two are again added to give us 0. And that's it. We are done with the synthetic division. Now, how to interpret this? So the interpretation is going to be the last number. The last number is always going to be the remainder, and the previous numbers are going to be the coefficients. The coefficients of quotient. Coefficients of quotient. So how to write the result over here? So we are going to say that the quotient, let's denote it with qx. Let me take a different color over here. Let's denote it by qx. So the quotient is going to be, the coefficients are 5 and 12, but we have to add the variable as well. So remember, the quotient will be 1 degree less than the divisor. So it's the dividend. So the dividend is of degree 2. So the quotient will be of degree 1 less than 2, which is 2 minus 1, which is 1. So this is going to be of degree 1. So it means that this is the coefficient of x, and this is the constant term in it. So 5x plus 12 is the quotient, and the remainder is definitely 0. And was this something which we got over here? Yes, 5x plus 12 was the quotient, and 0 was the remainder. And again, yes, we can definitely write this result in this format, so that remains the same anyway. So this is a way how the synthetic division works. It's really fast. It's really fast and gives us quick results, and the results are definitely the same in the same way, and we get all what we could have got had we approached the long division. So this is how the synthetic division works. So this was an example in which I showed long and synthetic both, but in the coming examples we are just going to proceed with the long division and see how the things work. All right, let's take another example over here. So we have 4x cubed plus 10x square minus 6x minus 20, and this should be divided with x plus 2. So the procedure says that we write the coefficients. So that's 4, 10, -6, and -20. Before writing the coefficients, always remember that this must be arranged in a decreasing order of the degrees. So degree 3 must be written first, then 2, then 1, and then constant term. So the degrees must be written in a decreasing order. Then we draw a L-shaped symbol, and then we change the sign of the constant of the divisor and write it over here. Then it goes like this. So the 4 drops down as it is. 4 times -2 is -8. 10 minus 8 is 2. 2 times -2 is -4. -6 minus 4 is -10. -10 times -2 is 20. And -20 plus 20 is 0. So from here, we get to know that the quotient is equal to, if you write the final answer, the quotient is going to be 4x square plus 2x minus 10, and the remainder is definitely 0. Why 4x square? Because the degree has to be 1 less than the degree of the dividend, which is 3. So it has to be, the degree must be 2. So, and these are in the decreasing order of the degrees. The coefficients are in decreasing order of the degrees. So 4 is for x cube, x square, 2 is for x, and -10 is for the constant, which is over here. But let me just mention these things as well over here. That what do we have to take care over here? That uh, polynomial, or the dx, must be in decreasing order, with respect to its degree. That is the first thing which we need to take care before proceeding for. That is the thing which we need to take care before proceeding to the synthetic division. So this is how it's gonna look like. Let's talk about another problem. Let's say we have -9x raised to 4 plus 10x cube plus 7x square minus 6, and this should be divided with x minus 1. So we need to set up in the way that first we write the coefficients. So that's -9, 10, 7, and -6. If you're going to write like this, that will be wrong, because notice that although the degrees are in decreasing order, but whenever you don't have a particular term in the power, let's say I have 4, I have 3, I have 2, but I don't really have 1. So if I don't have 1, I have to skip that place which was reserved for 1. So I'm going to skip that place which is reserved for 1, which is here, and then I'm going to write the constant. And since there is no x, so I'm going to write this with a dummy variable which is 0. So that's what I have to do. I cannot just skip that step entirely. I have to write 0 over there, which is called a dummy variable. And then I'm going to drop down the -9 over here. This will be 1 anyway. The divisor is 1. And now I'm going to drop down the -9 just over here like this. Then this becomes -9. This will be 1. This will be 1 again. This is 8. This is 8. So this is also 8. And over here we have 8. So we have 2. So this means that since the remainder is not 0, we can say that this is not a completely this doesn't divide it completely. So first we'll write the result as the quotient is 1 degree less than the dividend, so it's of x cube. So that's -9x cube plus x square plus 8x plus 8, and the remainder is 2. And since the remainder is not equal to 0, it means that x minus 1 is not a factor of dividend, which is this expression. But if the remainder comes out as 0, which was the case in the previous two questions, so definitely the remainder, definitely the divisor is a factor of the dividend. Let's talk about another question. It says that it's -18x cube minus 3x plus 3x raised to 4 plus 40. This should be divided with x plus 7. So before moving ahead, we cannot really start right away because notice that the divisor is not written in a sequential way. It should be in the decreasing order of the degree. So I'm going to rewrite this in terms of that. So that's 3x raised to 4 minus 18x cube minus 3x plus 40. This should be divided with x plus 7. And now I'm going to write the coefficient. So if I do that, I have 3, negative 18, and remember, there is no x square here, so I'm going to write the position of coefficient of x square with 0 as the dummy variable. Then we have negative 3, and then we have 40 over here. And I'm going to make a symbol like this, and then we have negative 7. So again, the usual process, the 3 drops down over here. So we have 3 over here, then this is negative 21. Negative 21, if it is negative 21 over here, then we have these two will be added. These two, when added, 20 and 30, this becomes a negative 39. So the numbers are big. You can definitely take the help of the calculator. So we have negative 39 multiplied with negative 7 gives us 273, which is dropped just like this. And then 273 is multiplied with negative 7 to give us negative 1911. And this is when added gives us negative 1914. And then when negative 1914 when multiplied with negative 7, it gives us a positive number, which is 13398. And 13398 when added with 40, it gives us 13438. So we can clearly say that this is the remainder. This is the remainder. So I'm going to write over here that this is the remainder. And the quotient is going to be 3x cube minus 39x square plus 273x minus 1914. Because why 3? Because the degree of the dividend is 4, so it has to be 1 degree less than that of the dividend. Let's talk about another question. Over here we have 2x raised to 4 plus 4x square minus 1. It has to be divided with x minus 1. All right. So again, the same procedure, we're going to set up with 2, then 0 because there is no x cube, then 4, then again 0 because there is no x, and then we have negative 1, and then we write 1 over here. So the procedure is that the 2 drops down, and then we have 2 times 1 is 2, 0 plus 2 is 2, 2 times 1 is 2, 4 plus 2 is 6, 6 times 1 is 6, 0 plus 6 is 6, 6 times 1 is 6, negative 1 plus 6 is 5. We notice that when we get a good practice of it, it's really fast. So the quotient is 1 degree less, so that's 2x cubed plus 2x squared plus 6x plus 6, and the remainder is definitely 5 over here. So that's how it's going to work. Then let's talk about a next question. In this question, we got to divide 4x cubed minus 8x squared plus 7x plus 7x minus 11. All right. It should be divided with 2x plus 1. So definitely we cannot divide this right away because the condition for the synthetic division is the divisor must be of the form x minus k. In this case, it's not really in the form of x minus k. That is of the coefficient of x is not really 1. So I'm going to show you both the methods, as in I'm going to show you the long division method in this case, and we have a long division method in this case, and then I'm going to show you the synthetic division in this case. So let's do the long division method first. So we have 2x plus 1, and then we have 2x plus 1, and then we have 4x cubed minus 8x squared plus 7x minus 11. So I'm not going to talk much about the process because I've already talked in the question 1. So I'm just going to write the final results. So this will come out as 2x squared. This becomes 4x cubed plus 2x squared. So if I subtract, this will be 0, and this will be minus 10x square. So this will be minus 5x here. This is going to be minus 10x square. I'm sorry, we have to write all the terms. So plus 7x minus 11. Then we have minus 10x square and minus 5x. I'm going to subtract once again. So this will be 0 and this will be 12x minus 11. And finally we have 6 over here. So with this becomes 12x plus 6, which is nothing but negative 17. So negative 17 is the remainder which we are getting from the long division, and this is the quotient. So let's do the same procedure again with respect to the with respect to the synthetic division. But the question is how to solve when this is not something which is allowed. So what we can do is, see, we have to find 4x cube minus 8x square plus 7x minus 11 divided with 2x plus 1. The only hurdle is the coefficient of x is not 1, right? So we can make it 1 by rewriting the divisor as, so this is how the dividend is going to look like. And we take the 2 as a common, 2 out from here. So if we do that, we are left with x plus 1 over 2, right? Because if 2 is taken as a common factor, this will become 1 over 2. And this 2 we can give to the numerator, which is the dividend. So 2 will be divided, each of the coefficient will be divided with 2 to give us the new modified dividend, and the divisors as 2x cube minus 4x square plus 7 over 2x minus 11 over 2 over x plus 1 over 2. And I think we are good to go. We can easily apply the synthetic division in this case now. So let's apply that. I think this is the usual process now. So it's going to be 2 minus 4, uh, 7 over 2 and negative 11 over 2, and they should be divided with negative 1 over 2, because that's how we get after changing the constants, changing the sign of the constant. So 2 drops down as it is. Negative 1 over 2 times 2 is negative 1. 5 drops, negative 5 drop, negative 5 comes here. Negative 5 times negative 1 over 2 is 1, is 5 over 2. Then 5 over 2 plus 7 over 2 is 12 over 2, which is 6. And 6 times negative 1 over 2 is negative 3. And negative 3, let's say 6 times negative 1 over 2 is negative 3. And negative 11 over 2 minus 3, and over here we have these two are added to give us negative 17 over 2. So let's see what is our final answer. What is our quotient is 2x square minus 5x plus 6, and the remainder is negative 17 over 2. It may look different because the remainder in this case was negative 17. But remember that in this case, the divisor, the dividend had all the terms which are twice of this. So it eventually remains the same. To prove that, I'm going to write the final answer for the long division over here. So I'm going to write it as dividend, which is 4x cube minus 8x square plus 7x minus 11. This, when divided by 2x plus 1, gives the quotient as 2x square minus 5x plus 6, and plus the remainder over divisor. So remainder is negative 17 over the divisor is 2x plus 1. It's 2x plus 1. Now, what if I divide both sides? What if I divide, I change the divisors over here. So if I do that, in order to keep this in the same format, so what I'm going to do is this can be written in the form of, notice this over here. This is written in the way that I'm going to take 2 out from here. So I'm going to do it over here. This for the remainder part. That's going to be negative 17 over 2 times x plus 1 over 2. I can write like this, right? And this can be written as negative 17 over 2 over x plus 1 over 2, which is exactly what we are getting, right? Because we have divided with x plus 1 over 2. And this is exactly what we are getting as well. We are getting as negative 17 over 2, which is when we divide this by negative 1 over 2. So in other words, both these answers are one and the same. So this is how we have to proceed with the terms which are not in the form of x minus k, but we can make it with some with some changes, we can bring it in that particular segment. And the last question which we have for this video is 2x cube minus 6x plus 7. This is when divided by negative x plus 2. Again, this is not in the form of x minus k, rather the coefficient of x is minus 1. So I'm again going to do the same activity, that 2x cube minus 6x plus 1 when divided with x negative x plus 2 can be rewritten as, I'm going to multiply negative 1 in numerator and denominator, which is allowed. So the numerator becomes negative 2x cubed plus 6x minus 7, and the denominator is x minus 2. And we are good to go with the synthetic division now, because these two are one and the same. So I'm going to get negative 2, 0, because there is no x square, 6 and negative 7. And I'm going to get 2 over here. So I'm going to, this drops down, this becomes negative 4, this becomes negative 8, this becomes negative 16, this becomes negative 10, this becomes negative 20, this becomes negative 27 over here. So this is the answer which we are getting. So finally, the quotient comes out as, the quotient is negative 2x squared, negative 8x minus 10, and the remainder is definitely negative 27. Right. So I hope these questions helps you to understand the procedure for the synthetic division and the changes which we have to make in case the divisor is not as per our as per the rules which are given for it. If you have any questions, please post it down in the comment section, and you can surely schedule a free session with me with the link which is given in the blog. So till the next time, please take care of yourself and have a nice day. Bye bye.